All right, guys, if you would please turn in your textbooks to page 515. We are on page 515 in our textbooks. All right, so we are looking at probability, so defining and representing probability. But first, let's go ahead and let's look at our warm-up here, because this is a great going back to looking at what it is. It's asking us to convert each fraction to a decimal and a percent. All right, so we're going to go ahead and convert this to a decimal. So that means I need to divide my two numbers, 5 on the outside, 4 on the inside. Well, 5 cannot go into 4, but it can go into 4D. And I believe that is 8 times. 5 times 8 is 40. So 8, 40. So my decimal is 0.8. Well, to turn a decimal into a percent, I need to move it 2 times to the right to get 80%. All right. Let's look at the next one. I have 100 on the outside, 7 on the inside. Well, it cannot go into 7. Can it go into 70? 0 times. Can it go into 700? 7. So my decimal is 0.07, but my percent is 7%. Let's look at number 3, 12 on the outside, 5 on the inside. Well, 12 cannot go into 5, but 12 can go into 50 4 times. 4 times 12 is 48. Bring down the 2, bring down the 0. 12 can go into 20 1 time. Subtract 8, bring down the 0. How many times can 12 go into 80? 6 times. And I'm left with, 6 times 12? Let's see, is 72. And then take a look, I'm left with 80. So it looks like the 6 is going to repeat. So I'm going to stop here. I move my decimal 2 times to get 41.6%. 41.6%. All right, I'm going to go over here for number 4. 25 on the outside. 24 on the inside. Well, 25 cannot go into 24, so I must have a decimal in a 0. Well, how many times can 25 go into 240? And it can go in there 9 times. So 25 times 9 is 225. Placeholder carry 5 and 1. Add a 0. Well, how many times can 25 go into 150? 6 times. And it's 0.96 or 96%. And then the very last one, 21 over 40. 40 on the outside, 21 on the inside. Well, it cannot go into there. So how many times can 40 go into 210? Which would be 5. So 40 times 5 is 200. 10 to 0. 140, so it would be 40, 80 would be at least 2 times. 20 left over. Well, 200 into 40 into 200 is 5 full times, which we learned already. So my decimal is 0.525, or the percent is 52.5%. 52.5%. All right. We're going to flip over to page 519, and we're going to revisit some probability that we learned the other day. All right, we are on page, let me write it up here, 519. All right, so it's asking us to determine the probability of rolling a number that is not even. Okay, so which outcome or outcomes make up the event of rolling a number that is not even? Okay, so I'm rolling a dice. So I'm going to roll 1 dice. And I know that my dice are numbers 1 through 6. All right. So out of those possible numbers, I could have 1, 2, 3, 4, 5, and 6. And my question is, which outcome or outcomes make up the event of rolling a number that is not even? Okay, that is not even. So I have the numbers 1, 2, 3, 4, 5, and 6. Well, I know that 2, 4, 6 are even. So my possible outcomes okay, or my probability of not even is 1, 3, and 5. My possible outcomes is 1, 3, and 5. Okay, actually don't write that down because that comes in right here. So calculating the probability of not even, okay, so calculate the probability of rolling a number that is not even. Well, how many outcomes did I have? I have 3 outcomes in all. And how many total outcomes did we have? Our total number of outcomes is 6. Well, 3 out of 6 is 1/2. All right, determine the probability of rolling a number that is greater than 4. Okay, so my number is greater than 4. Well, I still have 1, 2, 3, 4, 5, and 6. What are my outcomes of a number that is greater than 4? Well, I have 2 numbers, and my outcomes are 5 and 6. So then what's the probability of greater than 4? And there are 2 total outcomes out of 6 in all, which means I have a 1/4 chance of rolling a number that is greater than 4. All right, number 8. There we go. Number 8, determine the probability of rolling a number that is not greater than 4. So not greater than 4. All right, so my possibilities are 1, 2, 3, 4, 5, and 6. Okay. Now, I want to know what is the probability of not greater than 4. So anything that's not bigger than 4. Well, I have 1, 2, 3, and 4. So my probability of not greater than 4, I have 4 total outcomes out of 6 possible outcomes, which is 2/3. This is not 1/4, this is 1/3. All right, and looking back at number 7, I want you guys to notice something. Number 7 was asking the probability of a number that's greater than 4. Okay, well, wait, what's the opposite of being greater than 4? Well, not greater than 4. So if you look at this probability right here and this probability right here, these two combined are complementary events. These two are known as complementary events. It's the opposite of what the event was asking. So if I'm asking for greater than 4, well, what's the opposite of greater than 4? Not greater than 4. If you were asked at the beginning, what is the probability of rolling a number that's not greater than 4? Well, what's the complement of that event? It is rolling a number that is going to be greater than 4. All right. Okay. Let's look. All right, looking at activity 1.2, we're going to continue on. So in the previous activity, you calculated the probability of complementary events. Complementary events are events that together contain all the outcomes in the sample space. Okay, so one way to notate the complement event of A is not A. For instance, suppose that the probability is even represents the probability of rolling an even number on a number cube. Then the probability of not even represents the probability of rolling a number that is not even on a number cube. All right. So consider the rolling events from activity 1.1, questions 5 and 6, rolling an even number and rolling a number that is not even. What do you notice about the sum of the probabilities? Well, the probability of an even okay, is 3 out of 6, or we can simplify that down to 1/2. And the probability of not even is also 3 out of 6, which is 1/2. And I want to know, what do you notice about the sum of the two probabilities? Well, 1/2 plus 1/2 is equal to 1 whole. The sum of all of my probabilities together is equal to 1 whole, or 100%. Now, consider the activity from 1.1 for questions 7 and 8, rolling a number that is greater than 4. So probability of a number that is greater than 4, not 8, that is greater than 4, we found on the other side that it was 2 out of 6, okay, which that can reduce down to 1/3. And the probability that is not number greater than 4, we notice that as 4 out of 6, which we can reduce that down to 2/3. Okay, I want to find the sum of these two probabilities. So 1/3, 2/3. And what do we notice? We have 3 over 3, which is 1 whole. Okay, 3 over 3 to give me 1 whole. So what do we notice about the sum of any two complements? Well, we notice that the sum of any two complements will equal 1. We notice that the sum of two complements is equal to 1. All right. Looking at number 4, the probability of rolling a 5 or less on a number cube is the probability of 5 or less is 5 out of 6. Leah and Jasmine calculated the probability of not 5 or less, and their work is shown. Examine the differences between Leah's strategy and Jasmine's strategy. All right, so let's take a look at Leah. Leah did the probability of not 5 or less. She saw that the total outcomes of this, of what she needs, is 1. Out of all the outcomes total is 6. So what Leah did is she found the probability of a number not 5 or less. She found the probability of a number not 5 or less. She found her favorable over the total. Okay, let's look what Jasmine did. Jasmine did probability of not 5 or less is equal to 1 minus the probability of 5 over less, or is 1 minus 5 over 6 to give me 1 over 6. What Jasmine did is she took her knowledge of knowing that the two events added together, G-E-T-H-E-R, equals 1. She took her knowledge knowing that the two events, so this event and this event, added together equals 1. Then subtracted what she was given by 1 to find the complement. Okay, so she took her knowledge of knowing that the two events together, so probability of 5 or less and not 5 or less, so the complement events, the two events, added them together would equal 1. And she took that information, and so she took what she was given, that probability of 5 or less is 5 over 6, subtracted that from 1 to get what we are left would be 1 over 6. All right. 1.3, consider the spinner shown. All sections of the spinner are the same size. And the experiment consists of spinning the spinner 1 time. So how many possible outcomes are there in my experiment? Well, how many outcomes do I have? You should see 6 outcomes. Okay. And how do we know? We know that there are 6 individual sections. All right. Number 2 is asking, list the sample space for the experiment. I want to know, what could I land on? Well, I could land on a 1, 2, 3, 5, X, and Z. That's my entire sample space. Now I'm going to determine the probability for the events below. So I'm going to determine the probability of land on a letter. So describe the event and then the possible outcomes. Well, my event is landing on a letter. And how many times can I land on a letter? Well, there are 2 possible outcomes, and it is X and Z. So what is the probability that I will land on a letter? 2 out of 6, which can reduce down to 1/3. Determine the complement of this event. So if the event is landing on a letter, what's the complement of that event? Not landing on a letter. And what are all my possible outcomes of not landing on a letter? 1, 2, 3, and 5. So how many total outcomes do I have? I have 6 in all. And how many times could I land on something that's not a letter? 4. And that can be reduced to 2/3. Okay. All right. Number 4. Determine the probability that the spinner lands on an odd number. All right. So I'm going to rewrite my numbers here, or my outcomes. Okay. Determine the probability that the spinner lands on an odd. Describe the event and the possible outcomes. Well, what is my event? What do I want to happen? I want to land on an odd number. And how many odd numbers do I have? I see 3, 1, 3, and 5. So the probability that I'll land on an odd number is 3 chances out of 6 total chances, which is 1/2. So describe the complement of my event. So if my event is to land on an odd, what's the complement of that event? Not land on an odd number. And the outcomes of not landing on an odd is 2, X, and Z. Now, even though X and Z are letters, there's still a possible chance that I can land on that's not an odd number. So what's the probability of not an odd number? 3 out of 6, which can reduce down to 1/2. All right. Number 5, X and Z. Determine the probability that the spinner lands on a vowel. Describe the event and the possible outcomes of the event. Okay, so what is the event? What am I asked to find? Landing on an vowel. Land on a vowel. And I want to know, what are the outcomes that I could have? Well, I have to stop and think. What are all of my vowels? What do we know as to be a vowel? We know there's A, E, I, O, U, and sometimes Y. Do I have any vowels in my possible outcomes in my sample space? No. So are there any outcomes that's going to happen when I land on a vowel? The answer is not, or no outcomes. So what is the probability that I'm going to land on a vowel? Well, did I have any outcomes? No. It's 0 out of how many total choices? 6. So if my event was to land on a vowel, what's the complement of my event? Not land on a vowel. Okay, and what are all of my possible outcomes of not landing on a vowel? Well, 1, 2, 3, 5, X, and Z. So what's the probability that I will land on not a vowel? 6 out of 6, which is 1 whole. 6 out of 6, which is 1 whole. All right. So many times you will also be given a spinner that kind of looks like this. And we're told that this square spinner here is a game. And that if we land on B, we win a prize. But if we land on A, we do not win a prize. Okay? I want to predict each probability of landing on A or landing on B. Okay? But I want to do this as fractions. Okay? So what I'm going to do is I'm going to split my square in half. And then I'm going to split it in half one more time. I'm basically going to continue splitting each individual section in half, and I'm going to create 8 equal sections. So create an X through your square, a line, and then a line. Kind of like cutting a pizza. So how many sections in all did I divide my spinner up in? 8 total sections. Of those 8 total sections, how many sections are included in A? Well, I see 1, 2, 3, 4, 5 of my 8 are all A's. So I have a 5 out of 8 chance of landing on A. What about for section B? How many little sections do I have of B? I have 3. So the probability that I'm going to land on B is 3 out of 8 sections. All right. Activity 1.5. Okay, so we have gone all the way over to page 527. Okay, 527. We skipped 1.4. All right, activity 1.5. Suppose there are 2 blue, 3 green, and 5 yellow marbles in a bag. 1 marble will be drawn from the bag. List the sample space for the experiment. So I want to know what are all of the possible answer choices. So if I put my hand inside of the bag, what are all of the marbles going to be in there? So I know that my sample space includes 1 blue, 2 blues, includes 3 greens, so green, 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 and 5 yellows. 1, 2, 3, 4, and 5. Okay. So how many marbles are in my bag in all? Well, I have 10 marbles total inside of my bag. What's the probability that you put your hand in the bag and you're going to pull out a blue marble? Well, I see that I have 2 blues out of 10 total. So I have 2 out of 10 chance to get a blue marble. What's the probability that we pull out a green? Well, how many greens do you see? I see 3 greens. So 3 out of 10 total. And what's the probability of drawing a yellow? Well, there are 5 yellows, so you have 5 out of 10 chances to grab a yellow. So when the probabilities of all the outcomes of the experiment are equal, then the outcomes are equally likely, okay? An example of this would be flipping a coin. You have a 1/2 chance of heads and a 1/2 chance of tails. Are the outcomes in the marble experiment equally likely? So do I have an equal chance to get a blue as I do to get a yellow? The answer is no. More chance on yellow than any other color. All right. Then it's asking us to determine the sum of all the probabilities. So all I need to do is I want to add up the sum of all three of these probabilities. So the probability of blue is 2 out of 10. Probability of green is 3 out of 10. And the probability of yellow is 5 out of 10. Now, I know that I could have simplified 2 out of 10 to equal 1/5 or 5 out of 10 to equal 1/2. But if I did that, I would have 3 separate denominators that I needed to find a common denominator between all 3 to be able to add my fractions. So I just left them as the probability out of 10. So when adding fractions, my denominator stays the same. So I'm just going to add my numerator. 2 plus 3 is 5. Then 5 plus 5 is equal to 10. Well, what is 10 out of 10? It equals 1. Okay. Let's try it one more time. Determine the sum of all the probabilities of all the outcomes on your first spinner from activity 1.3. So I have my spinner again. What's the probability I'm going to land on a 1? Well, it's 1 out of 6. Probability of landing on 2, 1 out of 6. Landing on a 3 is 1 out of 6. Landing on 5 is 1 out of 6. Landing on X is 1 out of 6. And landing on Z is 1 out of 6. So I'm going to add up all of my probabilities together, and I'm going to get 6 out of 6, which is equal to 1 whole. So do you think the sum of all the probabilities for all outcomes of any experiment will always be 1? And the answer should be yes. Okay? And the answer should be yes. 1 is equal to 100% of your event. 1 is equal to 100% of your event. If you have any questions, please let us